Hi, so welcome back to chapter 3, Sound and Hearing. And for this video lecture, we will be talking about one of the most interesting topic in physics, which is your Doppler effect. Okay, so this will be the last topic that we will be discussing for this chapter. And I know that you can relate this one in your everyday scenario. Okay, so what is this all about? Okay, so what is Doppler? Okay, what is Doppler effect? Okay, so Doppler effect is simply a phenomenon where the frequency of sound changes due to the motion of either the sound source or your listener. So let's say for example, naka sa karsada. Okay? Nga naman yun, nga while a certain sound source is approaching you, magkaan naman og ka, kusog ang iyang um, sound. And then, pag mo nang siya kalayo sa imuha, magkaan naman po siya og ka, hinay. Okay? So it has something to do with what you call Doppler effect. And this is named after Christian Doppler. Okay? So, phenomenon where frequency is changing. Okay, the frequency is changing. So, while magkaanam og kuan, paduol sa imuha ang sound source, so na the frequency is increasing. So, the pitch niya is also changing. Okay? So, this is an example of your Doppler effect. Okay, so naka sound source and then you have a listener. So the velocity of the listener here is denoted by V sub L. The velocity of your source is denoted by V sub S. The speed of sound wave, since of course the medium here is your air. So V diha is denoted as the speed of your sound wave. And we have a convention in your solving a Doppler effect problem. So if you have a positive direction, so ang positive direction nimo is if you have listener to source. So ang listener, nakay source, ang imong listener is going to the source. Okay, something like that. So the value of your velocity should be positive. If you are moving away from the source, the value of your velocity should be negative. So this is the general formula for Doppler effect. So this is actually a formula if both your listener and your source is moving. So nakay frequency heard by the listener is simply equal sa imong wave speed, air nga wave speed plus velocity sa imong listener over wave speed, speed of your sound wave plus velocity nimo sa imong source times the frequency of your source. Okay, so ma'am, aha may zero, aha ang dili, aha ang positive, aha ang negative. So that depends upon the scenario in our problem. Okay, so para fully understand nato kung aha nato ni siya dapat gamiton o kung saan nato ni siya pagamit. So let's move on with our example. Okay, so in our example, okay, where is it? Okay, so sa atong example, we have okay, a police siren emits a sinusoidal wave with frequency equal to 300 Hz. The speed of sound is 340 meter per second. So if a listener L is at rest and the siren is moving away from the listener at 30 meter per second, what frequency does the listener hear? So again, we have to write the given. So the given is you have frequency, a police siren. So the police siren emits a sinusoidal frequency, meaning that's the frequency of your source. Okay, that's the frequency of your source, which is equal to 300 Hz. And then the speed of your sound wave is also given. Okay, the speed of your sound wave is given, and that is equal to 340 meter per second. If a listener L is at rest, so your listener L is at rest, what happens to the velocity of your listener? So of course, since at rest siya, it's not moving, so that will be equal to 0. So you have velocity of your listener which is equal to 0. And the siren is moving away from listener at 30 meter per second. So makita natin dito, no? Your Dili na ko siya ma-point out. So, ang imong police car, okay, is moving away from your listener at 30 meter per second, going to the right. So, nakay velocity sa imong source, which is equal kang 30 meter per second. Now, the question is, what frequency does the listener hear? So, we're asked to solve for the frequency of your listener. Okay, so using our formula for Doppler effect, so nakay frequency of your listener is simply equal sa imong sound wave, speed of your sound wave, plus speed of your what do you call this one? Your listener over the speed of your sound, plus the speed or the velocity of your source times the frequency of your source. So again, ang atong ipangita is already found on the left side. So all you need to do is plug in your values. So nakay 340 meter per second plus sa imong listener, which is at rest, so that is 0, divided by 340 meter per second plus velocity sa imong source, which is 30 meter per second, times the frequency of your source. So frequency of your source is already given, and that is equal kang 300 hertz. So if you're going to what do you call this one? Simplify this one, you should get an answer of 275.68 hertz. Okay, so this is the frequency nga madungog okay sa imong listener. Okay, that is 275.68 hertz. Okay, so this is a very simple problem. Okay, next let's move on with another problem. Okay, another problem. So same gyapon siya, a police siren emitting a frequency of 300 hertz and your speed of sound is still 340 meter. But this time, na siya changes. Okay. If the siren is at rest, so kakaina, the listener is at rest. This time, the siren is at rest. So, meaning the velocity of your source is now 0 since it is not moving. And the listener is moving away from the siren. So, your listener is moving away, okay, from your source. Now, we have a convention na we can get a positive value if listener padulong sa source. Now, in this case, ang nahitabo is si listener is moving away. Wala siya ni padulong but moving away. So, automatic, okay, it becomes a negative. Okay, negative ang iyang value, dili positive. So, negative 30 meter per second. Okay? And you're asked to solve for what frequency does the listener hear? So, still the frequency of the listener. Okay, so we're going to use the same equation. So, you have frequency of the listener is equal sa imong wave speed of sound plus the velocity of your listener plus speed of sound plus velocity of your source times the frequency of your source. Substitute, you have 340 meter per second plus velocity sa imong listener, okay, that is negative 30 meter per second, okay, divided by 340 meter per second plus velocity sa imong source, which is 0, times sa frequency sa imong source, which is 300 hertz. Okay, so if we're going to simplify this one, you should get an answer of 273.52 hertz. Okay, so this is the frequency that your listener will be hearing. Okay, 273.52 hertz. Okay, now, so we're done with koan. Listener is at rest. This example where your source is at rest. So, let's move on to a little bit complicated. So, atong palihokon ang duha kung unsa ang mahitabo. Okay. So, same gihapon, you have a police siren emitting a 300 hertz na frequency with speed of sound which is 340 meter per second. But this time, the siren is moving away from the listener. Okay. with a speed of 45 meter per second. Nakay velocity sa imong source, which is equal kang 45 meter per second. Okay, towards, and the listener relative to the air, and the listener is moving towards the siren. So, ang imong listener is nag-move siya padulong sa imong siren. So, if that happens, that means we're going to follow hindi na ako siya ma-point. We're going to follow our sign convention, which is positive. Okay, so meaning the velocity of your listener should be equal to positive 15 meter per second. Okay, so the question now is still the frequency of your listener. Okay, so we're going to use the same equation. Frequency of listener is equal kang speed of sound plus the velocity of the listener divided by speed of sound plus the velocity of your source times the frequency of your source. So nakay 340 meter per second plus velocity of your listener, which is 15 meter per second, divided by 340 meter per second plus sa imong source, that is 45 meter per second, times sa imong frequency, okay, this one, so you have 300 hertz. Okay, so if we're going to simplify that, you should get an answer of 276.62 hertz. Okay, so in this case, if both are moving with this velocities, so ang madungog ng frequency sa imong listener is 276.62 hertz. Okay? So, okay, that's it for today. This is the last topic. Okay, so I hope you get, okay, where is it? Okay, so I hope you get the concepts and how to plug in and how to use your formula. Okay, so thank you for listening for chapter 3, and I hope you learn a lot on this topic on sound and hearing.